Hey guys, so here is our video for lesson 1.2 for geometry. In this chapter we're talking about segments now, or in this section, so this is all about segments. So let's get some definitions out of the way. So our first definition is a postulate, and sometimes we call a postulate an axiom. Okay, so basically that's just a rule that we accept without proof. So when we get to theorems and corollaries, those are things that we have to prove that are true, but these things are just accepted that they're true. And to me, most of them are kind of like obvious things that you're like, duh, we don't need to, we just know that that's true. Okay, so that's a postulate, and sometimes that's called an axiom. They mean the same thing. So our next definition is a construction, and this is what we're going to need our compass and protractor for. So construction is like just a drawing, but we can only use a compass, which is like, well, mine looks funny with these things, or a straight edge. So most of the time we use a protractor. I just have this little tiny ruler I'm going to use today, but it just has to be a straight edge. And the thing about the constructions is that we can't measure our stuff with the units that are on there. We just have to do it using the ways that they did back in the day when they first came up with all this stuff thousands of years ago. Okay, so just the compass and protractor or straight edge, no measuring. Okay. Our next definition is distance. So when we talk about distance between 2 points, it's the absolute value of the difference of their coordinates. Okay, so you could be talking about their vertical distance or their horizontal distance, but you subtract and then you do the absolute value of that number, because distance always has to be positive. So we're going to talk about congruent segments today, and when segments are congruent, that means that they have the same length. So congruent segments are just segments with the same length. So we can talk about these two segments, and we can say that the segments are congruent, and that's because it has these marks here, and if you have those two marks on two segments, that means they're congruent. So those are congruency marks. So I said segment CD is congruent to segment EF, or we can talk about that their lengths are equal, so that their sizes are the same. So when we say equal, we're talking about their sizes. When we say that they're congruent, we're talking about the shapes themselves. If they're equal, are their sizes the same? Yes. So I know it kind of is confusing using the two different things, but we use the congruency marks when we're talking about the shapes themselves. And if you notice too, I put the marks over them, so it's segment CD is congruent to segment EF. Here is CD is equal to EF, which is equal to 17 inches. So one way to tell the difference between these is if you're saying it's like a number, you always use equal and you don't put the mark over the segment. But if you're saying that the shapes are the same, we use the congruencies and we have the marks. Okay, so I know that it seems all like the same thing, but the notation is important. Okay, so then we're going to talk about our first postulate. Okay, so this is just something that you assume is true. Okay, so it's called the segment addition postulate, and the segment addition postulate tells us that if we have a point on the interior of two other points, so B is on the inside of AC, so we have this whole segment AC, and we have B on the inside, so it kind of breaks up the segment into two other pieces. If we add those pieces together, AB plus BC, then we're going to get the whole thing. So the two parts added together equal the whole. Does that make sense? The pieces added together equal the whole thing. Okay, so the left side plus the right side equals the whole segment. And that's pretty much what the segment addition postulate is telling us. Add the parts together and you get the whole segment. Okay, so let's practice some examples for the segment addition postulate. So go ahead and look on the inside of your foldable on the left side. Okay, so like I said, the left side plus right side equals the whole. So you could write that if it helps you. Left plus right equals the whole. And now we'll be able to figure out what parts we add together. So the left side of our segment is X. The right side of our segment is 1. And then they like to do this thing down here to show you how big the whole thing is. So a lot of times they'll do that. Okay, and that's what that means. It's not another segment. You see how it's like measuring from this part to this part, and it shows you that it's 10. Okay, that's just showing you how big the whole thing is. So we set up our equation. Now to solve for x, we'll subtract 1. So we get that x equals 9. So if we take a look, we knew what the whole segment was. So TP is equal to 10. OP equals 1. So how big is TO? Good. TO is just X, so X is 9. So TO is 9. Very good. Okay, go ahead and pause your video and try number 2. And I want you to try to set up number 3, please. So pause your video and then come back and we'll talk about those problems. Did you pause? You better pause. Okay, so here we go for number 2. We set up our equation. The left side is 14, the right side is X. Get it to 30. So we get 16, and then that means that this piece was just 16. Okay, so for number 3, we had left plus right equals the whole thing, but now this time our equations are a little bit more complicated. Okay, so the left side plus the right side equals the whole thing. So we did a little bit more algebra there to get that value of X. So I got 6. And then when we plugged it back in, DO was 26 and OG is 4. Okay, so if you looked at question number 4, then you would have realized that there was a typo there because it said the same thing as question number 3. So I made up a new problem for us. So we're going to say that BO is 7x minus 3 and OP is x plus 1, and then the whole thing is 38. Okay, so left side, 7x minus 3 plus the right side equals what the whole thing is of 38. We get that? Very good. So now we'll combine like terms. So remember, our x is on this side. We have 8x. Negative 3 plus 1 is negative 2 equals 38. So inverse operations. So 8x equals 40. And then divide by 8. So x is 5. So we can plug those back in. So BO was equal to 7x, so 7 times 5, minus 3. So 35 minus 3 is 32. So OP, we can plug in x there, so x plus 1 is 6. But remember, if the whole thing's 38 and this part is 32, 38 minus 32 has to be 6. 5 plus 1 is 6. Very good. So let's take a look at example number 5. So this one, they don't give us a picture here, so we have to make our own picture. So it says that points A, B, and C are collinear, so that means they all are on the same line. So I'm just going to draw a line with 3 points. Point B is in between A and C, so that means that point B is in the middle, and A and C are the endpoints. So it says AC is equal to 3x plus 1, so from A all the way to C, so that's the distance of the whole thing, is 3x plus 3. AB is this piece, negative 1 plus 2x, and BC is 11. So go ahead and pause and try to set up your equation and solve. So we'll solve for x. Pause your video. Okay, welcome back. So left plus right equals the whole thing. We end up with x being 7. I hope we did okay on that. I plugged it back in to find the other pieces, even though it just said to solve for x. I can't help it. I have to do math when it's there. So we end up with x equals 7. So remember, if you have any questions, circle it, start, highlight it, write it down somewhere so that way you'll be able to ask when we get to class. Okay, so for question number 6, it wants us to determine whether segment AB and CD are congruent. So let's go ahead and real quick graph those points. Okay, so A is at 8, 3. So here's point A. B is at negative 1, 3. So here's our segment AB. So remember, to find the length of that line, we do the absolute value, the difference of that, absolute value of the difference. Okay, so are the y values changing to get from A to B? Good, it's not. It's just a horizontal line, so the y's aren't changing, it's the x's. So we'll do the absolute value of their x's. And it really doesn't matter which one you put first. So the x-coordinate for here was 8. The x-coordinate for here was negative 1. So that means that that line is 9. 8 minus negative 1 is 8 plus 1. The absolute value of 9 is 9. So that means if we were to count over, they would be 9 boxes apart. Okay, so let's try the other segment and see if they're the same. So C is at 510. and this one is at 5.3, D. So I hope you're looking at it and saying, well, those are definitely not the same, because they're not. But let's do the math, because that's what geometry is all about. So this time, is it the x's changing or the y's? Very good. The x's are both 5, so it's not the x's, so it's the y. So 10 minus 3 is 7. So that means we can say that AB is not equal to CD, or we could say that AB, remember, if it has a line through it, it means not equal. AB is not congruent to CD. Very good. So really we're just seeing how big the lines are and then saying if they're congruent or not. We could have just counted the boxes, you know, until you find it. I like doing the math way better. Okay, so let's look at the back and our last thing that we're going to talk about today. So now we're doing construction. So I know you might not have your compass and your straight edge with you, so I want you just to follow along and we'll go back over this in class. But I'm going to show you how to do it now. We also have the steps there. I'm not going to read them to you because you can read. I'm just going to do it and talk my way through it. Okay? So the first thing we're doing when we're copying a congruent segment, so basically this is just saying make another line that's the same size as JT. So the first thing you do is just draw a line. And we're going to draw it so it's intentionally bigger than what JT is. Okay? And then we're going to put an endpoint on one side. I could have done it on the other side, but I like to do it on the left side. So now we're going to use our compass. We'll talk about the compasses in class. Let me zoom out a little bit more, and how like the best way to use them is. Okay, but you always just hold the pointy end and move it freely with using your hand. Okay, so since my point is on this side, I'm going to actually flip it over since I'm right-handed and put it by my right hand because that makes it a lot easier. So now we're trying to make this line, but we want it just as long as this line. So I'm going to measure how big this line is with my compass, not with my straight edge or measurement or ruler. We measure it with our compass because back then when they first started these, they didn't have rulers. Okay, we're just trying to make two lines the same size. We don't care how big they actually are, so how many inches or centimeters or whatever. We just want to know that they're congruent. So I open my compass to be the same size as that original line. And sometimes I'll just draw a little arc there just to make sure it touches that point, okay? So then I'm going to take my pointy end, and it's called the stationary end, and come put it on the other stationary end of the line that I drew. I'm going to swing it. So now where that arc and the line intersect, that means that they are congruent. And that's it, okay? So I'm just going to name it with some random letters. So that means we just made JT, I don't know, I'm just going to write D, be congruent to segment AB. And that's it for copying segments. So I'm going to walk through the other one real fast. If you got it, I guess you could stop, but you know, it's always awesome to watch construction, so I wouldn't if I were you. So remember, first step is to draw a line. Make sure it ends up bigger than the original line. I'm going to flip my paper upside down. Okay, so I'm going to use my compass to measure HW. Wonder why I called it HW. Oh, I forgot to do my point. Sometimes that happens. Okay, so I have my point. I use my point, swing my arc, and where they intersect, I make a new point. So now I have congruent segments. So I'm going to name these, let's say CD. So HW is congruent to CD. And that is it, dudes. So that is how you construct congruent segments. So remember, write down any questions you have. We'll practice going over this in class. And that's it. Werner out.